And that takes us to example 3, HTTP response by customizing the building web file server in Golang. Before we get into the description, they probably define this term, web server, a bit more carefully. Okay. Think back when we just have HTTP and HTML defined. At the time, by web server, we meant a web file server essentially, because all we do are just to download web objects, upload web objects. But nowadays, the term web server is a lot more general. You see, in the older time, when web server is mainly doing the file upload download, what we do is we provide in the URL the path and the file name, and then we get the object we want. But if you look a little bit carefully these days, the URL a lot of times do not look like they contain the path name and the object name. Take YouTube as an example. As you're watching this video, what does the URL look like? Does it look like it's a path name followed by the file name of the video you're watching? It actually doesn't. It looks more like a string, somewhat cryptic. And somehow when you use this URL, it gets you the video you're looking for. YouTube, the web server there, is actually more like a video database. Okay? That is taking that string as the query and then looking the database for the video you're looking for and then send you back the video. The reason that we're calling this backend database of video maintained by YouTube as a web server is because the data, the video, as well as the query are sent over HTTP. So you see nowadays, when we say web server, we actually meant to say that whichever distributed services, as long as you're sending messages and data over the internet using HTTP, then we call this a web service. And the server, they're providing the content that people are looking for, the web server. It's probably easier for you to see this. The web server of YouTube there. It not only needs to interpret the HTTP requests coming in. After grabbing the string in the URL, there needs to be also script there, analyze the string, grab the keys, and then use those keys to query the backend database. Therefore, video can come in here and then pushed to the user. So you see, the script part of the web server, it's very domain specific. It's very service dependent. It can never be a general solution provided by anybody. Therefore, the general web server implementations these days often have a building part, particularly the building file server part. That part is general. There's also a customizable part, and that is the part that the developers of the service can then do the script programming there and editing to the entire web server. And that is what Golang's building web server is architected exactly. There's a more fixed part, more specific part that does file download, file upload. There's also a customizable part that allows the service programmers to do the query processing. Now, think back example number 2. So what we're doing there is actually using the file service part of Golang's building web server. Okay. We give the web request, and the server there gives us specific response. So the impression might be more that the Golang's building web server is working in a very specific way. But no, okay, what we're seeing there is the file server part of it working in a very specific way, right? But the web server, in fact, is actually made very customizable. Later on, you will see the file server part can also be customized by overriding some of the functions or borrowing some of the functions existing. And example 3 here is to showcase the customizability of the building web server. Okay. A client can send an HTTP request to the web server, and the web server is going to look at the URL And by looking at the prefix in the URL, the server decides whether this is going for the file service part of the server or the customized part of the web server. Now, if it goes to the customized part of the web server, the service developer there will need to add additional program, therefore they can process the query there, the HTTP request further there. And finally, let's start handler response.go and copy this block of code over there. Let me explain the code a little bit so that we know what to expect in the demo. So this web server here is going to do two things. When we're taking an HTTP request message, we look at the URL. If the prefix of the URL matches this, /hello, that URL is going to be passed further to this function HH. Okay? And the HH function is associated with the hello handler. Hello handler is already defined here, and this is more like the script we were talking about doing the customization thing. So what we're doing here is just to print a line through the socket back to the web browser. So this is sending a short message, hello world, back to the web browser. Second is, if the URL prefix matches just a /, then we call this function HTTP strip prefix and then / again. So this is actually to remove the / in URL, take the path and the file name, and give it to the building file server. So FS here, as you see, we're calling the file server, the building file server. And that file server will be starting at the directory we're starting the Golang program. So you see, this example here is a web server, very simple one, taking the URL. If it matches prefix /hello, then it goes to the hello handler function. If it matches just /, then it goes to the file server function, which is looking for the file object and return the object to the user. Now let's give example 3 a test run. So run handler response.go. All right, started. And let's curl. And let's, use the hello prefix and see if it does return hello world. Could not resolve host 127.0.0.1. Oh, I'm sorry. Should be column. Yeah, there. The client here, the web browser here, is getting the hello world. Okay. Now let's try giving it a file name. Okay, a file object to download. So let's try server test.html and see if we get the file. There we go. We could also request what was that? String response.go. There. And why don't we query a non-existing file .htm, and it says 404 page not found. So you see the functionality of the web server here. It matches the prefix of the URL. Okay, hello prints hello world. Just / grab the path and the file name and feed it into the building file server. And therefore we get the objects we're looking for, or the 404 page not found message.